Hello, my name is Sang Ho, and welcome to the second webinar of the CCLAS webinar series. Today, we are going to look at the QC module of the CCLAS application. Thank you for attending. From the list of attendees, I can recognize quite a few people whom I have had the privilege of meeting previously. But for those whom I have not met, I trust that this webinar, and indeed through this series of webinars, you will find CCLAS as an application to be suitable for your organization in relation to LIMS. The topic we are going to cover today include the following. Introduction. For those who are not familiar with who Datamine is as a company and the solution that we're offering, I will take a couple of minutes to do a brief introduction. Then we'll discuss the concept and the principles of QC. That is to answer questions around why do we need QC in a lab. Next is the QC configuration. That is where I'll show you how to put the principles into practice by showing you the step-by-step on how to configure QC samples. That is to answer questions such as, how do I do it? And lastly, QC evaluation. That is to answer the question of, what can I get out of QC module? Okay, let's start the session by going through the agenda. Datamine is one of the few mining software companies offering our clients a comprehensive software solution across the whole mining value chain, starting with the capturing of exploration data all the way through to managing the inventory, logistics, and commodity trading. Throughout the mining value chain, one significant piece of solutions stands out. Its use and its application spreads the whole mining value chain from end to end. That is the LIMS solution, which helps streamline laboratories, processes, and improve the laboratory efficiency. CCLAS is our LIMS, as our LIMS offering to the mining industry. CCLAS is one of the components within an integrated solution suite of software called the IMS, which is Intelligent Mining Solutions, that consists of 4 modules. Mindscape, the mine planning and modeling solution. Mine Market, an inventory and logistic management and commodity trading solution. Production accounting is a metal balancing and reconciliation solution. And CCLAS, our LIMS offering to the mining industry. All right, let's look at a few principles surrounding quality control. When we going through the process of doing analytical test work, unavoidably, we encounter errors from time to time, which include sampling error, contamination, problem with accuracy, and likewise problem with precision. Some errors are controllable, some are not, and for those controllable errors, that's where our QC module will help. So what does our QC module offer in terms of functionality? It helps assess the accuracy and precision of your analytical work. It helps detect contamination and a whole host of other error that is controllable. And it does that by including a number of techniques of report and extensive set of QC charting. When we speak about accuracy versus precision, there's a subtle difference here, which I thought for those who are working with QA/QC on a day-to-day basis, that is obvious. But I thought for completeness sake, and for the sake of those who are not familiar with the concept, a simple diagram would help. What we're aiming to do in the laboratory is to have our test work of high accuracy and high precision. Yeah, this is the final diagram here that we're aiming at. However, often we find that our techniques, our analytical work, okay, may have high accuracy but lacks precision. Or sometimes we are very precise but lack accuracy. What we don't end up doing though is having a situation where we lack both accuracy and precision. That's why we need to check the performance of the lab using QC. When it comes to replicate, there is a difference between two types of replicate. One is called duplicate, one is called replicate. In CCLAS context, they are different, slightly different, as illustrated by this diagram here. Okay, let's go into a bit more detail. When we receive a sample, during the process of sample preparation, we may split that into two split or multiple split. And that might go through milling, crushing, milling, and digestion. And split number 2 will go on to the analysis stage, which produces a result number 3. Whereas split 1 could go through the analysis stage multiple times. In this case, the second time it goes through will give us the second result. And in CCLAS context, we call it replicate. The original sample, we call it, the unknown sample. And the result coming from the second split is result number 3, which we call duplicate. Okay, let's have a look at our configuration. How do we do it using CCLAS? A typical workflow at CCLAS lab will go through. The top part of the diagram involves setting up the configuration of the laboratory. And then the bottom part is the daily execution, the daily work that we do. Today, we're going to look at the QC module, the setting it up, the configuration. And then later on, we will show you how we use the QC module to evaluate our test work. Right, when it comes to configuring our QC samples, we have some fundamental concept here. One is called the QC type, in which we configure the number of QC samples and the placement. All right. So in this diagram here, I have for my batch of 20 samples, I need to have 1 blank, 2 standards, and here 1 replicate. That results in a batch of sample looking like the right-hand side here. So where do I want my blank sample? I can nominate that by blank position number 1 here. And then where do I want my 2 standards? I have the keyword random, R&D, which you can really see here. And CCLAS will take that at the time of creation of the job and randomly insert the standards into the place. And lastly, 1 replicate for the rack of 20 will go into at the end here. All right, so I'm going to show you how this is done in CCLAS. Let's pause the PowerPoint for now. Using my method module, I open up my, for example, AS01 scheme here. On the page called quality control, I have the control of, within the block size of 20, in this case 19 plus 1 is 20. I want one blank, and whether it is an absolute 1 per rack or proportionally. Okay, I say 1 absolutely, even though my number of sample for the batch could be just a couple, but I still want one blank. And then where do I want to put my blank? It is here, first position or second, etc. Yeah. And how many standards in the rack? 2. And where do I want that to be? Randomly. I could specify a specific number, but in this case I use the keyword random. And how many blank, how many spike, how many replicate, etc. Okay, that kind of definition is fairly flexible. All right, once we've done that, it is ready to be used by our next process, which is job creation. When we create a job involving AS01, then automatically CCLAS will insert 1 blank, 2 standard, and 1 replicate in a block of 20 samples. All right, we'll see that in action in a minute. That is the first step of configuring QC samples. Next is the parameters, the 2 important parameters for standards, okay? Namely expected value and tolerance. All right, how do we configure that in CCLAS? Using the same module, which is method, I now have a section where I can define my QC standards. And I have one standard called ORIAS 68A, which has been configured to be a standard, a valid standard for AS01. If I open up that, in my details tab, I can have as many analyte as this standard is applicable for. So being gold analysis, I can open it up and I put in here my expected value. Okay, so in other words, this standard, so-called ORIAS 68A, when it's analyzed by AS1 for gold, my expected value is 3.89 ppm. And the second parameter I have control over is the tolerance, which I have 2 options, either using absolute tolerance or relative. When it's absolute tolerance, then I need to specify my lower range and my higher range. That could be, for example, here 3, just for argument's sake, and then 4.1 and 3.5, for example. Okay, based on my experience and experiment, I got to have these 2 tolerance. Or I can say, well, my tolerance is not absolute. It's about 7.5, plus or minus 7.5, above or below my expected value. Right. So these 2 parameters, expected value and tolerance, will give us a total control of our standard samples, which, come back to our PowerPoint, will be as follows. So the middle line here represents our expected value. And using the mathematical calculation. Okay, we have two set of control limits. What we call the upper action limit and lower action limit is roughly about 3 standard deviation above or below expected value. And the upper warning limit and lower warning limit represent 2 standard deviation away from the expected value. All right. So as far as standard samples are concerned, we use those 2 parameters, being expected value and tolerance, which I've shown you how to configure. When we talk about replicate and duplicate, likewise, we have also 2 parameters that control how CCLAS assess the pass or failure of our replicate or duplicate samples. And these 2 parameters are the limiting repeatability, in this case is 10, and the statistical detection limit we set to 0.5, which is from the start should be the same as the analytical detection limit, which is the instrument detection limit. We will revise our statistical detection limit over time when we have sufficient determination or result that allow us to come up with a better estimate for our SDL. All right. And then using these 2 parameters, we can assess the pass or failure of our replicate and our duplicate result using the formula here. Precision, which is represented by this line here, okay, is equal to 100 times our SDL, statistical detection limit, divided by our concentration plus our limiting repeatability. All right. Okay, so that is a bit of background of our QC module, or the principle that we use. Next is the evaluation of QC result. How do we do that, and by what means? Let me show you how. We have a number of use cases here. Use case number 1. Okay, QC checking during data entry. It is real time. It offers the analyst a timely display and information about whether or not this rack or this batch of sample has passed QC. Right. It uses color coding to indicate the status of the QC. Okay. Yellow being warning, either upper or lower warning, and red being fail. Let me show you that by using the second program called data entry. All right. I have a job that is set up for this session. Open it up, and I have one scheme, which is called AS1. So at the moment, I have no result. So using my built-in instrument reading capabilities, I select my instrument, select my analyte, and then it offers me to select the file that I've just generated from my instrument. Next is to start reading from top. So very quickly, I've got over 50 results has been read into my worksheet here. And then at this point in time, CCLAS evaluate whether any of the red samples, such as blank, standards, and replicate, are pass QC or not. A yellow code means that it's either slightly high or slightly low. As you can see, the pop-up message here saying my expected value is 3.89, but my actual value is now 4.12. It is slightly high, but it is still under the failing limit, which is 4.18. Can you see the right hand towards the right of this message here? All right, so it's still okay. It's be the warning. The second warning comes from the second standard reading. Okay, so it is below our expected value of 3.89. However, it's still acceptable because our action limit is actually 3.59, as you can see. Next, we have a reading of 3.13, which is well below 3.598. So obviously that fails QC. Okay, so CCLAS flag that as a red. Next one is a replicate. This is a replicate of sample 49, which is 2 above. So the original sample or the known reading is 4.56, but the second reading is 2.76, which is not right. Something's wrong there. All right, so that can be right. So this is very timely and very valuable QC check. Okay, so let me save that. But before I save it, let me just minimize that for now. I'll leave that for now before I save it because I want to save that to for the review of our SPC module later. So that is the one of the many applications for our QC module. Okay, so the first use case, QC check during data entry. The use case number 2 is the performance of our laboratory. Okay, if I go back to my previous diagram here, when doing data entry, all our QC result will be saved in a separate area for long-term storage. Unlike the production data, which is job-based data, which will be archived off after 3 months, 6 months, or a year, QC history never get archived. From this QC history, we are now doing the laboratory performance analysis. All right. QC, which stands for QC analysis. From the QC history database or table, I now have the option to choose my QC type and my standard, sorry. I select my standard, my scheme, and then when apply. From this period to this, from this date to this date, I have now 218 samples or reading for this standard. This is the result. I can generate my report, which offers me a glimpse of how good my lab has been doing for the last 6 months, 12 months. So it gives me the mean, the bias, and the mean and max value, and a whole host of calculation, which is very useful for my QC analysis. I could also go on to display the different chart. X chart. Second chart, histogram. It looks pretty good. However, it is spreading out a bit to the left and to the right. Yeah. And lastly, we have Q-sum chart, which stands for cumulative sum. So the sum of errors are added together, okay, from 1 to the last point. And there's a trend here you can see. While it is not obvious in the previous 2 charts, but within Q-sum chart, it shows that there's a bias, a positive bias, which is trading up. All right, so that is the QC analysis for standard. Next, let me show you the QC analysis for replicate and duplicate. So I use replicate for now. So for the pair of unknown and replicate, I want to consider or to assess the whether it's pass or fail QC using those two parameters we mentioned before. For gold, I have about 738 pair of results. Similarly to my standard analysis, I can now generate a report for replicate analysis, different stats. However, it's very meaningful for those who are interested in finding out how the lab is doing. And then similarly to the standard case, we have a different chart that offers a glimpse into how good we are doing in terms of replicate. Next one is our coloration. Okay, our correlation coefficient is pretty good here, 0.99999, so almost perfect. And then last but not least, our P curve, which represent our precision curve. Okay, if a pair value falls in the red region, it is a failure. So in this case, this lab is doing pretty good. Doesn't seem to have any failure at all. All right, so that's use case number 2. Assessing the laboratory performance for a period of time. The next use case is SPC, Statistical Process Control Charting. This is a dynamic real-time charting that is applicable to those labs that has a processing plant. So I'll do that by studying this Auto SPC module. So I want to start my this chart here by double-click on it. So as you can see, it flashes every few seconds or a couple of minutes, every minute or so. It has been configured to automatically refresh after a certain time period. So this is where I now go back to my data entry form and do the save. If you could pay attention to the last point here being 3.94, which is read a while ago. If I now save it, so what I want to show you is these readings for standards will be plotted real time, okay? After the waiting period of, let's say, 30 seconds. So that is what we offer in the form of SPC. There you go. Because the result hasn't gone through a thorough check and redo the test, so all over the place. But that is SPC. Okay, to recap, the programs that we have used so far to illustrate the functionality of the QC module include method, the one that we use for configuring our QC, number of QCs and placement, and also the expected value and etc. Data entry for real-time QC checking during the analysis time. QC, which is for our laboratory performance analysis. SPC charting. Auto SPC. Now, Auto QC is an automated export of QC report and chart. Let me just show you quickly. Auto QC. So instead of generating the QC report or chart every day manually, I could just do that and say, well, for the last 300 days or 60 days or 30 days, generate my QC control chart and ready for that. So I can schedule that to run every morning and it will be here. So if I go to my the folder called QC data. I will have it here. All right, so this is a report freshly generated. So that offer me all the chart and report. And if I'd like to, I can also include all the data as well. That helps with your QC management. All right, in the short 30 minutes or so, I have explained to you the principle of our quality control module, how we do it, and then what use can I get out of it. I'd like to pause now for questions.